welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. In the previous lecture, we have seen 2-in-1 multiplexer and also we have learned few basics of multiplexer. And now let us try to understand 4-in-1 multiplexer. If you want to go and verify 2004 ECE Electronics and Communication Gate paper, there is a question called how many number of 2-in-1 multiplexers are required to implement one 4-in-1 multiplexer. How many number of 2-in-1 multiplexers are required to implement one 4-in-1 multiplexer? There is a question from GATE. Let us try to understand first how to implement 4-in-1 multiplexer so that we will try to understand how many number of 2-in-1 multiplexers are required to implement 4-in-1 multiplexer. Sir, here 4-in-1 multiplexer, 4-in-1 multiplexer. The name itself indicates that. Here 4-in-1 multiplexer, which means it is having, multiplexer is a combinational circuit, we know that, and the number of inputs for 4-in-1 multiplexer, as the name suggests, we can say 4 inputs, and we can say that number of outputs are 1. We can write it as outputs are 1. This is what. And coming to the block diagram of multiplexer, if you see the block diagram of multiplexer, internal circuit diagram of multiplexer, here I want to write like this: 4-in-1 mux. Sir, 4-in-1 mux, and it is having 4 inputs. 4 inputs, which are, I can say that I0, I1, I2 and I3. Sir, all these are, we can say, data inputs. All these are data inputs. And now the only one output is Y0. And now, sir, to operate 4-in-1 multiplexer, we need here we need two select lines, which are S0 and S1. These two are calling as select lines. Select lines are also called as control lines. Select lines are also called as control lines. And the second point is implementation of truth table. Here second point is truth table. How to write a truth table? Sir, here we have two select lines. Sir, for these two select lines, I want to write here S0 and S1. What is the output, sir? Here output is Y0. We can say that Y0 is the output. And now for these two select lines, there may be a chance of 4 combinations, input combinations, which are 0, 0, 0, 1, and now 1, 0, and now we can say 1, 1. These are the 4 input combinations. Sir, let us see, when we apply 0, 0, what will happen? And when we apply 0, 1, what will happen? Let us try to understand. This is output Y0. Sir, here the moment when I apply 0, 0, which means S0 equal to 0 and S1 equal to 0, what will happen? S0 equal to 0, S1 equal to 0, automatically I1 will be connected to Y0. So that whatever the data which is present in I0 will go to directly Y0. We can say here Y0 equal to, simply we can write as Y0 equal to I1. Here Y0 is I1, we can write. And now the second step, here when we apply 0, 1 as inputs, which means S0 equal to 0, and now here S1 equal to 1, the moment when we apply, what will happen, sir? Here S0 is 0, S1 equal to 1, automatically I1 will be connected to Y0. So that Y0 equal to I1. Y0 equal to, here this is I0, and then this is what? I1. And now the moment, third one, here 1, 0, which means S0 equal to 1, and now S1 equal to 0, then automatically Y0 equal to, we can say I2 will go to output. We can say output is out I2. Here I2, and finally S0 equal to 1 and S1 equal to 1, then Y0 equal to finally I3, which means all three are disabled, and finally I3 will be connected to Y0. So that here the output will become as here I3. This is what the logical expression. And now based upon this truth table, now let us try to write the logical expression. Sir, here the third point is logical expression. Logical expression. Logical expression. How to write, sir? Y0 equal to. Here the first one, Y0 equal to. Here when S0 is 0 and S1 is 0, can I say that S0 bar, S1 bar, yes, into we can say I0 plus. Here I1 is output when S0 bar, because S0 is 0, and S1 because S1 is 1. Can I say that S0 bar, S1, I1, yes. And now third one we can write it as like this. Here S0 and then S1 bar, because S1 equal to 0. Here S0, S1 bar into I2 plus third one is we can say S0 is 1 and S1 is 1. So that S0, S1 into we can say I3. This is the equation. Sir, this is the logical equation of logical expression of 4 into 1 multiplexer. Based upon this logical expression, let us try to construct a logical circuit also. Construction of logical circuit. Here the fourth point is logic circuit. How to construct it? Sir, here we have two select lines, S0 and S1. Here we have four inputs, which are inputs are we can say I0, I1, I2 and I3. Select lines are S0 and S1. Now here this is what, here S0 bar, and this is we can say S1 bar. Now let us take a connection. The first combination is this one, S0 bar, S1 bar, I0. Here first one is first connection S0 bar, S1 bar, and we can say I1. There is one AND gate. And the second connection is here S0 bar, S1 and I1. Here S0 bar, here S1 and I1. We can say that this is the second connection. And third connection is S0 and S1 bar. Here this is S0 and this is S1 bar, and we can say I1 or I2. And finally S0, here this is S0 and this is S1, and third one is I3. Finally one more AND gate. For these four AND gates we need to draw one OR gate, that is called Y0, and these are the connections. Because OR gate can be accepted many number of inputs to produce output. So we are just connecting these four AND gates to one OR gate. So this is the logical circuit diagram of 4 into 1 multiplexer. Now this is the question. Here the question is, how many number of 2 into 1 multiplexers are required to implement this particular 4 into 1 multiplexer? We will see that is in the next class. Please note it down. If any doubts are there, please ask now itself. No doubts? Thanks for watching. Please do subscribe.